do the thing presentation. And we all know that modern society is heavily dependent on fossil fuels. And most of people are aware that the supply of these fuels is finite. So scientists work hard to find out some substitutes like solar powered, wind powered, like this kind of renewable energy and even nuclear power. However, last class we have already told you that this kind of power has their disadvantage. Therefore, more and more people use their imagination to figure out new way to generate power. And today I'm going to show you some spatial and creative way to produce electricity. But before my introduction, I have to explain the meaning and the principle of piezoelectric effect for you beforehand. Because the following ways I'm going to introduce to you is all based on this theory. Piezoelectric effect means that the crystal material can generate an electric charge when it is compressed, twisted, or pulled. And the reverse is also true. As the crystal material compresses or expands, an electric voltage is applied. In brief, when crystal material is compressed by external forces, it can produce electricity immediately. And we have seen wave power, wind power, and solar power. But how about rain power? So the first way I'm going to show you is rain power. A scientist and his colleague in France are fantasy about using those diminutive droplets of water to actually power useful creations. And after they used computer models to find out just how much energy could be created by rainfall landing on piezoelectric materials, they determined that between 1 nanojoules and 25 microjoules of energy could be generated per job. This may work not so well, but it's still a benefit. And the second one is piezoelectric dress. Scientist Wang Zhongling and his colleague insert nanowire into textile fabrics, which can generate power when rubbed against, pulled and dragged, or just when a breeze blew over. And the outfit feature electricity generating fibers around the eyeballs and the hips. This means that as the wearer walks, bend, or just shake their body, the mechanical stress conjured up energy which is stored as voltage in a built-in battery where it can presumably be used later for charging the handheld gadget. And the second one is supermarket generates piezoelectric power in parking lot. A supermarket in UK has installed kinetic plates in the parking lot that use the weight of shopper's car to pump a series of hydraulic pipes, which in turn drive a generator. The system is set to generate up enough to power the store's checkouts. And the last one I'm going to introduce is watt to generate power. Researchers in Japan created a new way to generate power. They laid 4 panels on the sidewalk of Tokyo railway station. When passers-by step above the sidewalk, panels can generate electricity. It is reported that, on average, every people can produce 0.5 watts of power if stepping above 45 square centimeters panels twice. And they even created spatial shoes to produce electricity. It looks like that. The feature of this spatial shoes is that there's a small generator installed in the soles of the shoes to produce electricity. Theoretically, as long as the user wears the shoes and just keep walking, the electrical energy produced from the shoes can supply the electric needed of iPod eternity. And now let's see a video.
Capturing energy from motion has long been a dream of inventors, but now it is a reality. Idaho National Laboratory inventors working with research partners at M2E Power, have succeeded in converting the power of motion into electrical generation and battery charging. The technology they developed, M2E motion to energy power generation systems, are not only commercially viable, they have created buzz among mobile device technophiles, green energy advocates, and military developers. This breakthrough technology eliminates the need for recharging, taking mobile devices off the electrical grid. No longer will people need to plug in to get the power needed for smartphones, digital cameras, or mobile audio players. The M2E solution uses lightweight self-charging power units that convert kinetic energy from walking or vehicular motion into electricity. It uses an efficient microgenerator, small enough to fit into D, AA, AAA, and cell phone batteries. It can even be scaled to microchip-embedded power systems. The price for M2E products will be similar to conventional rechargeable batteries, but M2E systems will last twice as long because a far less taxing self-charging algorithm is used. With more than 1 billion cell phones sold worldwide last year, eliminating cords and doubling battery longevity has a major environmental benefit, reducing cost and conserving vampire energy drained by battery chargers in standby mode. Like current rotary dynamo or linear generators, the M2E system is based on Faraday's laws, stating that a magnetic structure moving through a wire-wound coil generates electricity. The breakthrough behind M2E power generation is the invention of a new magnetic architecture that combines creative use of materials and coil design to harvest energy, even from lower frequency movement. M2E also uses an innovative compressed and unbalanced magnetic field, now an important part of the invention. The design improvements permitted macro and micro motions to cumulatively generate charges with up to a 700% plus improvement over state-of-the-art kinetic generators. A test at a leading university found that one self-charging battery on the market produced 2 milliwatts at 3 hertz in 5 minutes, while M2E produced 9.75 milliwatts at 2 hertz in the same time period. Battery life can be measured in years, not hours or days. M2E First is being developed to ease the military's battlefield burden, which has proliferated to over 500 different batteries for mobile devices. M2E will also revolutionize the mobile device marketplace, with many commercial applications. However, soon, M2E developers will begin pursuing scalable applications from nano to macro. That means development at the nano level for medical and electronic applications, as well as macro for large-scale wind, tidal, hydro, and transportation power systems. M2E is beginning with batteries, but its potential is truly unlimited.
Okay,